We assume we are Earth's first industrial civilization. But what if the geologic record holds the faint chemical ghost of a predecessor, a society that rose and fell millions of years before humanity ever existed? Let's turn our gaze away from the start or end of the universe and focus instead on the ground right beneath our feet. A simple but profoundly unsettling question waits for us there. What if we are not the first? Not the pioneering thinkers, builders, or explorers of this world? Imagine that long before pyramids or satellites, another civilization rose to complexity on Earth and then completely vanished. Welcome to Mythic Index, a sanctuary for lost legends and forgotten timelines. Here, we peel back the layers of history to reveal the myths that shaped our world, from the whispers of ancient stone to the mysteries of the cosmos. If you wish to ensure you can always find your way back to this archive, please subscribe now. This is not a journey into mythical, lost continents or theories of alien tourists. The idea concerns an actual, homegrown civilization, something biological and intelligent, perhaps in ways we don't fully comprehend. It would be a society that lived and died so long ago the planet may have entirely forgotten it. While this premise sounds like the setup for a science fiction story, it is also a serious scientific question, one that has been quietly considered in geology labs and cosmology conferences for years. The real puzzle is far more subtle than discovering skyscrapers under Antarctica or smartphones in coal seams. The fundamental question is, if an advanced civilization existed millions of years ago, could we even tell? Would any of its traces survive the slow, relentless grinding of Earth's geology? Or would everything, cities, tools, language, even bones, have been recycled back into rock and soil, now indistinguishable from nature? To even begin to search for such a ghost, we have to adjust our thinking, slowing our perspective down to the immense, grinding rhythm of plate tectonics. This journey isn't a quick trip through human history, but a deep dive into the planet's own biography, written in layers of crust, silence, and heat. Understanding whether another intelligence could have existed requires us to first grasp the sheer scale of time involved, and second, to appreciate just how ruthlessly efficient Earth is at erasing its own past. Our usual frame of reference for ancient history, the Egyptian pharaohs, the creators of Stonehenge, or the first scribes pressing symbols into clay, only covers a few thousand years. Stretching back to the very dawn of our civilization takes us, at most, 10 or 12,000 years into the past. In planetary terms, that is an insignificant flicker of an eye. This period, which feels to us like an incomprehensibly deep past filled with enough mystery to pack every library on Earth, is actually far closer to our present moment than to nearly anything else in the planet's long story. The Earth's true age is staggering. We're not talking about millions of years, but billions. The planet has been around for roughly 4.5 billion years. Throughout the overwhelming majority of that immense timeline, humans did not exist. For huge stretches, mammals hadn't yet appeared, and for even longer the continents were barren of any life. For eons, existence was confined to the oceans, where life either swam, waded, or developed in unseen microscopic forms. It might sound like an empty stage, but this was precisely when the bulk of Earth's history was recorded, one layer of rock at a time, in a language that is both slow to speak and prone to forgetting. Earth is not a meticulous record keeper. It doesn't save everything with equal care. Natural materials like wood simply rot away, metals corrode into dust, and even bones can eventually dissolve. Time is an active, destructive force, not a passive backdrop. It relentlessly buries, melts, crushes, and reconfigures everything. Over these vast periods, mountains are born only to be ground down to nothing, great oceans form and then vanish, and entire landmasses are pushed and pulled across the globe, smashing together and tearing apart. The planet's entire surface is fundamentally remade every few 100 million years. From this perspective, the real surprise isn't that evidence disappears. The truly astonishing thing is when any trace manages to survive for millions of years at all. Let's entertain a thought experiment. Picture an intelligent species emerging roughly 100 million years ago, deep within the age of dinosaurs, but well before their extinction. It doesn't matter if they were upright or not, or even if they lived on land or in the sea. Perhaps their civilization never relied on stone or metal, finding no need for them. Their technology might have been based on principles we can't even imagine. Let's say they flourished for a time, creating what we would recognize as a culture or society, before they vanished. Whether through a sudden catastrophe, a gradual shift in their environment, or by simply fading away over time. Fast forward to today, and we are left with the question of whether any sign of their existence would remain for us to find. This brings us to a difficult realization about our own place in the world. Our legacy is far more fleeting than we imagine. The towering skyscrapers, sprawling highways, vast libraries, and orbital satellites that define our age are not designed to withstand deep time. If a modern city were abandoned, nature would begin its reclamation within just a few centuries. After a few thousand years, its original form would be barely recognizable. But after a few million years of relentless erosion, tectonic shifting, and the crust being pulled back into the mantle, the very ground it stood on would be transformed. Former land could be deep under the ocean, ancient mountains could be scattered as dust, and the vast majority of what we built would be utterly gone. This line of thinking isn't a flight of fancy. It's grounded in our scientific understanding of geology and archaeology. We already know that finding traces of relatively recent prehistoric human life is an exceptionally difficult task. This rarity isn't due to a lack of activity from our ancestors, but a testament to how effectively our planet recycles and erases the past. Before we drift deep into the ancient past, take a second to tap the like button. Think of it as placing a bookmark in history, helping others find this quiet corner of the internet. The fossil record itself offers a perfect example of this planetary recycling. Its notorious patchiness isn't a reflection of a scarcity of life, but instead highlights the incredibly strict criteria for anything to become a fossil. The vast majority of living things simply return to the system after death. They're consumed, they break down, or they're washed away. For an organism to achieve fossil status, a perfect storm of events is required. It must be buried quickly, its organic matter replaced by minerals, and then shielded from the forces of erosion. Even then, the resulting rock has to endure, find its way to the surface, and be discovered. When you stretch that minuscule chance across tens of millions of years, the true scope of the challenge becomes clear. And this principle of decay doesn't just apply to living tissue. The artifacts of a civilization, from buildings to tools, are also surprisingly fragile. Metals are prone to corrosion, most plastics degrade when exposed to sunlight or soil, and even mighty concrete will inevitably crumble if not maintained. It follows that a civilization from the deep past, particularly one that didn't build colossal stone monuments, could have vanished without a single, obvious trace. This line of thinking leads to a fascinating question. Have any scientists taken this possibility seriously? It turns out they have. In 2018, researchers Gavin Schmidt and Adam Frank co-authored a paper that explored this exact topic. Their goal wasn't to argue for the existence of an ancient industrial civilization, but to tackle the more practical problem of how we might even begin to look for one. They playfully titled their thought experiment the Silurian Hypothesis, a nod to a species of intelligent reptiles from a classic British science fiction series. The core of their work was a question of method. What kind of geological footprint would an industrial society leave behind over vast timescales? And could it be that such evidence already exists in the rock, but we're simply misreading it? They suggested looking for subtle clues, anomalous chemical signatures and telltale markers like shifts in carbon isotope ratios, strange pockets of rare elements, or synthetic molecules that nature wouldn't produce. They were approaching the problem like geological detectives at a crime scene millions of years too late, forcing them to analyze faint stories left in the very wallpaper of the planet. This raises an unsettling thought. What if the absence of evidence isn't evidence of absence, but simply the natural state of a planet that wipes its surface clean every few 100 million years. Complex societies are messy. Their energy consumption, farming, mining, and industry all leave distinct fingerprints. The problem is that even the clearest fingerprints eventually fade. If a forgotten society had its own version of an industrial revolution, would any lingering effects be detectable today in our climate records or sediment cores? The answer remains profoundly uncertain. We can see this process happening in real time, as our own global impact is actively being etched into the Earth's geology. This has led many to propose we've entered a new epoch defined by our influence, the Anthropocene, uniquely characterized by novel layers of ocean plastics and concrete-laced soil. But before we can even begin searching for the geological fingerprints of some ancient Plastocene or Concretocene, we have to tackle a far more fundamental question. It's essential to step back and establish what we truly mean by civilization. What kind of signature are we actually trying to find, and what would scientifically qualify as one? Our casual, modern idea of a civilization is often quite specific, conjuring images of towering skylines, complex governments, and written languages. This perspective is not only recent, but also incredibly narrow, as it fails to encompass the immense diversity of even known human societies. While some cultures erected massive monuments and built extensive road networks, others left fainter marks, like subtle changes in land use or the evolution of language, yet both are rightfully considered civilizations. Archaeologists and anthropologists use a more precise definition, typically identifying a civilization by a collection of key characteristics. This list often includes urban centers, a division of specialized labor, centralized governance, agricultural surplus, organized religion, social hierarchies, symbolic communication, and long-distance trade networks. It is crucial to remember, however, that not every civilization will display every one of these traits, and some might express them in very unfamiliar ways. This means that when searching for a truly ancient, forgotten society, our thinking must be much broader. The goal isn't to find the fossilized remnants of pyramids or computer chips, but rather to spot the signs of deliberate complexity, social, technological, or ecological patterns that could not have arisen by chance. We're hunting for indications that a group of organisms coordinated their efforts on a large scale over long periods, driven by purposes more ambitious than mere survival. It's more useful to view civilization as a spectrum of complexity rather than a single, fixed destination. This spectrum leaves a vast middle ground between basic existence and planet-wide engineering. Imagine a species that used tools to create structures that outlasted their individual lifespans, or a culture that developed systems for storing and transferring knowledge, all while intentionally altering its environment. In evolutionary terms, these are monumental leaps. A fantastic real-world example is the 9,000-year-old settlement of Çatalhöyük in modern-day Turkey. It had no streets, no grand monuments, and no writing system. Instead, it was a dense cluster of homes built wall-to-wall, with residents entering through openings in their roofs. Despite this unusual layout, it is recognized as one of the world's earliest urban centers. This is because the physical grandeur isn't the point. The underlying pattern is. The evidence points to coordinated construction, prolonged habitation, and shared customs for rituals, burials, and food production. Even without impressive architecture, Çatalhöyük demonstrates sustained, collective behavior across many generations. The clues become even more delicate as we look deeper into the past, where the first signs of human symbolic thought appear as tools, carved objects, and the use of pigments, artifacts that suggest forethought, memory, and perhaps even belief. This represents a form of technology, not by our standards, but in its own context, proving that minds were capable of abstract reasoning. With that framework, just picture a civilization that flourished not 10,000, but 10 or even 100 million years ago. What kinds of traces could we possibly hope to uncover? As we begin to unravel these lost timelines, leave a comment with the name of the ancient civilization that fascinates you the most. Let's see which era calls to us tonight. The answer to that question depends almost entirely on what they were like. A major hurdle is our own tendency to project our image onto the past. We're conditioned to associate intelligence with familiar signs like tools, cities, language, and our modern digital world. But there is no rule stating that intelligence must mirror our own. Imagine a civilization that constructed its world from organic materials, wood, plant fibers, and animal products. None of those would survive the ages. We might uncover skeletal remains from their burial rites, but without any lasting artifacts alongside them, the profound meaning of those rituals would be entirely lost to us. Their whole history could vanish if they never developed writing or used a system that we simply couldn't identify as such. The odds of finding them become even slimmer if they inhabited environments that are notoriously bad for preservation. Any society that emerged in a rainforest, a swamp, or along a coastline would have its physical footprint erased in just a few centuries, let alone millions of years. This isn't about them hiding, it's a consequence of time. A non-industrial civilization might have a social structure that leaves no material evidence, communicating visually, chemically, or through behaviors so alien we lack the words to describe them. And that leads to a perplexing problem. Would we even know what we were looking at? Take, for instance, a simple termite mound, which to our eyes might just seem like a large pile of dirt. Yet from an engineering perspective, it's a masterpiece, complete with internal climate control, advanced air circulation, and dedicated resource storage. These termites construct their home collectively, cultivate fungus for food, and function together as if the colony were one living thing. Without knowing what to look for, we could easily dismiss it as a naturally formed hill. Imagine that structure scaled up 1,000 times or buried under sediment for millions of years. Any sign of its intelligent design would likely vanish entirely. This illustrates why searching for lost civilizations requires a dual mindset, blending the skills of both an archaeologist and a biologist. The search goes beyond finding ruins. It's about detecting patterns, anomalies, and breaks in the natural order. We'd be hunting for unusual mineral concentrations, shifts in sediment inconsistent with known geology, or peculiar isotope ratios. Anything that hints at an unnatural presence doing something out of the ordinary. We also have to consider the factor of time. To leave a lasting signature, how long would a civilization need to persist? From a geological standpoint, the answer is surprisingly short. Humanity's industrial activities have reshaped our entire planet in only a few centuries. While this period represents a mere dusting in the sedimentary record, its chemical footprint is undeniably profound. We have introduced greenhouse gases, synthetic compounds, and nuclear isotopes into the system. Were we to disappear overnight, the evidence of these changes could remain detectable for tens of thousands, perhaps even millions of years. Perhaps the real issue isn't about whether a civilization existed before us, but rather if our methods for finding one are correct. Our search is biased. We look for familiar evidence like fossils, ruins, and tools. What happens, though, if the clues are far stranger, more subtle, or hidden in locations we have never considered exploring? To fully explore this possibility, our perspective must expand to the scale of deep time, across entire geological epochs, not just centuries. This requires understanding the powerful forces of erasure, learning what endures, what vanishes, and the reasons behind it all. The most effective way to hide something forever isn't to bury it or destroy it with fire. You simply have to let it sit on the planet's surface and be patient. Given enough time, far more than days or decades, geology will take care of the rest. The planet is not a static stage. It is a dynamic system that breathes, shifts, and consumes, ensuring that nearly everything built upon it is ultimately erased. This process is largely invisible in our daily lives, where landscapes appear fixed. We perceive mountains as eternal, rivers as unmoving fixtures, and cities as if they were always there. A geologist, however, perceives the world differently, seeing immense motion in seemingly solid objects. Given enough time, The most resilient rock will bend, break, or flow, and the highest mountains will eventually crumble. Our planet's surface is in a state of constant renewal, which makes anything placed upon it inherently temporary. The whole process begins with weathering. Forces like rain, wind, frost, and heat relentlessly chip away at any exposed material. You see it as cliffs slowly erode, powerful roots shatter concrete, metals rust away, and all organic matter inevitably decays. In a surprisingly short time, this means grand buildings are reduced to ruins, and those ruins later become little more than unrecognizable mounds of debris. Knowledge grows when it is shared. If you know a fellow seeker, or just someone who needs a peaceful escape into the past, feel free to share this video with them. For those mounds of debris to last, they would require a geological miracle. Preservation demands special circumstances, like being flash frozen, buried rapidly in an arid climate, or otherwise sealed away from the elements. Without such luck, time simply erases them. Another relentless force is sedimentation, the slow and steady accumulation of soil, dust, sand, and ash that blankets the landscape layer by layer. While this burial can sometimes act as a preservative, it can also crush and warp whatever it covers. Over eons, these layers compress into solid rock, while any organic matter within them either disintegrates or is replaced by minerals. A few million years down the line, an entire city might be reduced to nothing more than a faint impression in a slab of limestone, if any trace of it survives at all. Then you have to contend with the planet's own restlessness, tectonic activity. Our world's crust isn't a single, solid shell, it's a jigsaw puzzle of massive plates drifting on a liquid mantle. These plates are constantly crashing together, splitting apart, and grinding past one another. This movement is responsible for earthquakes, the rise of mountain ranges, and the creation of new ocean floors. Crucially, it also drags old seafloors down into the Earth's mantle through a process called subduction. This isn't just burial, it's total annihilation. Entire sections of the ocean floor, along with anything on them, sediments, fossils, or even cities, are gradually pulled beneath continents and melted back into magma, effectively erased from existence. Consider this. The average age of the ocean floor is a mere 200 million years. That might seem ancient, but on a planet that's 4.5 billion years old, it's practically brand new. This implies that the vast majority of our planet's seabed has been completely recycled multiple times. Any civilization that thrived on a coastline or an island could have had its entire physical record literally melted. While continents are more durable, they are far from being a perfect archive. Relentless erosion grinds them down, massive glaciers scour them bare, and volcanoes blanket them in fresh layers of lava. Landscapes transform as forests expand, deserts shift, and rivers carve new paths. Even gigantic scars from asteroid impacts can vanish. What appears permanent to us is usually just a temporary phase in a process of constant flux. The Grand Canyon is often seen as a pristine library of Earth's history, with its rock layers stacked like pages in a book. The reality, however, is that this book has entire chapters torn out. Geologists call these missing sections unconformities, huge gaps where either no sediment was laid down or existing layers were completely eroded away. These gaps are a stark reminder that the geological record is not a continuous story, but a fragmented quilt, pieced together from the few scraps that managed to endure. And that endurance is the exception, not the rule. Take the fossil record, our primary tool for studying ancient life. It is profoundly incomplete. The vast majority of living things never become fossils. Of the tiny fraction that do, we only discover them by chance when erosion or digging brings them to light. The misconception is that fossils are abundant and we just need to find them. The truth is that fossils are astonishingly rare and most have been permanently destroyed. If preserving the actual bones of an organism is that unlikely, imagine the odds for cultural artifacts, tools, buildings, or technology. Even for our own relatively recent history, artifacts just tens of thousands of years old are often just fragments. A flint knife, a shard of a pot, or discolored soil marking where a post once stood. Archaeologists painstakingly reconstruct entire societies from these tiny scraps, because that's usually all that's left. With that in mind, the challenge of proving that a civilization existed millions of years ago becomes almost impossibly steep. The issue isn't simply a matter of not having found the ruins yet. The real problem is that the probability of anything surviving across such vast timescales is infinitesimally low. For a trace to persist, it would need to have been in a geological safe zone, a place that somehow avoided being melted, scoured away, or buried too deeply. Think about how we find evidence of massive asteroid strikes. These impacts carve out craters hundreds of kilometers wide, yet many are now nearly invisible, worn down and filled in over millions of years. Sometimes, the only way we know they're there is by detecting faint gravitational anomalies or slight differences in the rock. Our popular image of a fossil is often shaped by museums, where we see flawless dinosaur skeletons perfectly assembled, as if the creatures simply laid down to rest and were instantly turned to stone. The truth of paleontology, however, is far messier. The vast majority of real fossils are found as shattered fragments, partial imprints, and compressed shapes that bear little resemblance to that pristine ideal. That any fossil exists at all is a minor miracle, a product of pure luck combined with a highly specific sequence of environmental conditions playing out over immense spans of time. Even under the absolute best circumstances, fossilization is the dramatic exception, not the everyday rule. This means the story that the rocks tell us is inherently incomplete, heavily edited by chance, and frustratingly quiet on the most important details. While the fossil record is one of our most powerful tools for peering into deep time, it provides a profoundly distorted picture. Trying to understand the past with it is like attempting to reconstruct an entire film from a handful of torn still frames, a few damaged strips of film, and a random collection of subtitles. For every single species we have identified from a fossil, it's estimated there could be hundreds more that disappeared without leaving a single trace. Many simply never fossilized, while others had their remains destroyed long after they did, and countless more likely remain buried in places we have yet to look. This is a critical point when we consider ancient civilizations, as it means we are searching for clues within a library that already has most of its books missing. The process of becoming a fossil relies on a long and improbable checklist of factors. It's all about how and where an organism dies, the specific kind of sediment that buries it, and how quickly that burial happens. Then you have to hope scavengers don't get to the body, that the ground remains geologically stable for eons, and that natural erosion or tectonic shifts eventually reveal the fossil without obliterating it. The odds are astronomically stacked against preservation from the very start. And to make things even more difficult, the very places where life has always thrived, coasts, floodplains, and forests, are terrible for fossilization because they are simply too active, wet, and exposed. Now, if preserving bone is that hard, imagine the challenge of preserving artifacts. We're talking about tools, structures, and entire infrastructures, items that don't have the natural starting durability of a skeleton or a shell. The probability of their survival plummets even further. Even something as resilient as a stone tool becomes almost impossible to date or properly identify if discovered out of its original context. A sharply chipped piece of rock could be an ancient cutting tool, or it could just be a rock that was broken in a landslide. Without telltale patterns of use or other associated artifacts, it's often impossible to know for sure. On top of that, most of the materials a technological society relies on are far more fragile than bone. Metal corrodes into dust, fabrics and plastics decompose, and wood rots away, unless they are sealed in a rare, oxygen-free environment. But what if our industrial signature wouldn't even register as artificial to someone studying our distant remains? Millions of years from now, a future geologist uncovering layers filled with strange polymers, concentrated rare earth elements, and unusual metal alloys might not recognize them as the remnants of a civilization, especially if all other context is gone. Picture the discovery of a thin layer of titanium dust within a 100 million-year-old sediment core. While it would certainly raise questions, it could just as easily be dismissed as a geological anomaly. This highlights how interpretation is just as critical as observation. That brings us to a factor often overlooked in these discussions: bias. This isn't just about what gets preserved, but about how we analyze what survives. We tend to see what we expect to see. The notion that a technological society might have risen and vanished millions of years ago doesn't fit comfortably within most established scientific frameworks. Consequently, unless the evidence is absolutely overwhelming, it's far more likely to be classified as natural variation or an unexplained quirk in the data. This isn't due to scientific negligence, it's a reflection of how the process works. Science prefers the simplest explanation that fits all the known evidence, and proposing the existence of ancient, vanished civilizations is not a simple explanation at all. This is precisely why the fossil record can't tell us everything. It only tells us what the planet permitted to be saved. It tells us what we, by chance, happen to find. And it tells us only what we are able and willing to interpret. It cannot give us the full story of life on Earth, and it certainly cannot tell us the complete history of intelligence. Yet we aren't limited to just bones and artifacts. We possess other tools that search for different kinds of signals, subtle signs in the soil, shifts in the atmosphere, and strange quirks in the chemistry of rocks. These are traces left not by physical bodies, but by large-scale processes. This is evidence that doesn't rely on fossilization, evidence that isn't about bones at all, but about what happens when a species starts to fundamentally change the planet it lives on. This is when intelligence leaves a fingerprint not through its tools or cities, but through chemistry. In 2018, two scientists named Gavin Schmidt and Adam Frank posed a question that was simultaneously wildly speculative and scientifically grounded. They asked, if an industrial civilization had existed millions of years before humans, would we be able to detect it in the geological record? They were not arguing that such a civilization did exist. Instead, their work was an exploration of how science could even begin to look for one. In doing so, they gave this profound question a name: the Silurian Hypothesis. The name is a nod to a classic British science fiction show where intelligent reptiles, the Silurians, had once ruled the Earth long before humanity. But the hypothesis itself is far from science fiction. It is a serious exercise in testing the absolute limits of geology and paleoclimatology. It's about asking whether our own vast impact on the planet is a unique event, or if it could possibly resemble something much older, a similar signature hidden deep within the Earth's ancient layers. The core premise is straightforward. If an industrial society like ours had emerged, say, 50 or 100 million years ago and then vanished, what kind of signature would it leave? Crucially, could those traces survive the immense geological forces of erosion, burial, and tectonic churning over such a vast period? The scientists started with a known quantity. Our own civilization is already leaving permanent geological fingerprints. We are changing the atmosphere's composition, altering the ocean's chemistry, and depositing synthetic materials like plastics, pesticides, and industrial byproducts into the environment. These are long-lasting, planet-wide changes currently being written into the Earth's layers. The question naturally follows: which of these changes are the most durable, and could we tell them apart from our own if they were made by a much older civilization? The paper suggests a few major categories of evidence to look for. The first is geochemical anomalies, or unusual shifts in the ratios of stable isotopes like carbon, oxygen, and nitrogen. For instance, burning fossil fuels alters the carbon isotope balance in the atmosphere, and this shift gets locked into sediment and ice cores. Finding a similar spike in the deep past could suggest an industrial process. Another major category involves synthetic materials. Modern society creates plastics and chemicals that do not exist in nature. Many of these compounds degrade very slowly and could theoretically survive in some form for millions of years. We already find microplastics in modern sediments everywhere. Discovering ancient layers with similar artificial polymers would be a profound puzzle. There is also the direct evidence of fossil fuel use. An industrial civilization needs energy, and burning carbon fuels would leave behind not only CO2, but also physical byproducts like coal ash and fly ash. These could create distinct, detectable layers, much like we can find layers of ash from ancient volcanoes. A final signature is mass extinction. Human activity is causing a rapid drop in biodiversity, especially among large animals, which leaves a clear mark in the fossil record. A similar event in the past, lacking a clear natural cause, like an asteroid or volcanic event, might point toward an industrial influence. However, the challenge lies in distinguishing these signals from natural events. Many of these potential markers. To grasp what our civilization's footprint truly is, and to estimate its permanence, consider a fascinating if bleak scenario. Imagine that every person on Earth disappeared in an instant, no catastrophe, just an empty planet. What would happen after a year, a century, or even a million years? This thought experiment is incredibly useful for seeing what kind of mark a society like ours leaves, and for understanding just how long that evidence might actually last. For the initial few days, an eerie sense of normalcy would persist. The lights of our cities would continue to shine, vehicles would sit unmoved, and aircraft would rest on their tarmacs. This illusion would shatter swiftly, however, as the automated systems we rely on begin to falter without human supervision. The grid would go dark as power stations cease operation, and pipes would run dry as water pressure drops. The slow decay of our buildings would commence, not from a sudden disaster, but from the simple, relentless fact that our creations demand constant upkeep to survive. It would only take a handful of years for the natural world to begin its aggressive reclamation of our urban landscapes. Green shoots would push through asphalt crevices, while powerful roots would begin to buckle sidewalks. Rooftops and untended gardens would become fertile ground for seeds carried on the breeze. Wildlife would follow, with rodents and birds leading the way for deer, coyotes, and in some areas, even apex predators. The clear distinction we once made between the urban environment and the wild would rapidly dissolve. In major metropolises like Shanghai or New York, the failure of water pumps would cause subway systems to flood in mere days. Above ground, steel skeletons of buildings would begin to corrode, and panes of glass would crack and fall. Over the course of just a few decades, particularly in humid regions, many structures would give way and collapse. Our seemingly robust concrete is surprisingly susceptible to the elements. Shifting temperatures and persistent moisture cause its internal steel rebar to rust, leading to cracks that compromise its integrity. Our road networks would suffer a slower, yet equally certain fate as plants tear them apart from below. Bridges, deprived of routine inspections and protective paint, would also ultimately surrender to gravity. Looking to the skies, our orbital presence would also fade. The satellites circling the planet would go dark as their batteries die and solar arrays deteriorate. Within several hundred years, the vast majority would fall from orbit and incinerate upon re-entry. Only the highest, most remote objects would remain as silent, slowly tumbling relics. Back on the surface, after a single millennium, the very signature of our civilization would be nearly erased. The towering steel frameworks of our cities would be reduced to piles of rust, and sun-exposed plastics would have broken down into countless tiny fragments. Anything buried underground would fare better, but only for a time. To find traces of something so thoroughly erased, we have to learn a new language. Geologists, for instance, perceive time in a fundamentally different way than the rest of us. They communicate not in years or centuries, but through the language of sediment layers, isotope levels, and data from core samples. Instead of tracking seconds and seasons, deep time operates on a scale of vast intervals and sweeping patterns, far beyond the reach of human memory, history, or even biology. To even begin searching for a potential predecessor civilization, we must first become fluent in this geological dialect, which reveals not recent events, but the epic stories inscribed directly into the planet's stone. Contrary to popular belief, our primary window into Earth's distant past isn't fossils, but the chemical composition and physical structure of sediment. This record is found everywhere, in ocean cores, lake beds, glacial ice, and the exposed bands of rock in cliffs and quarries. These strata build up slowly over eons, accumulating from dust settling in a lake, shells piling up on the seabed, or ash blanketing the land after a volcanic eruption. This process creates a remarkable natural archive, where every distinct layer holds clues about the state of the world when it was formed. We can think of this as the language of deep time, with a vocabulary consisting of elements like carbon levels, oxygen isotopes, trace metals, and even pollen grains. By reading these elements, we can reconstruct ancient climates, analyze atmospheric composition, and identify what plant life was dominant. The record also chronicles catastrophic events like asteroid impacts and mass extinctions, while occasionally hinting at something even more unusual. The clearest geological stories are found in environments that change very little, such as the floors of deep oceans, the beds of ancient lakes, and the compressed layers of polar ice caps. To read this archive, scientists extract long, cylindrical samples known as cores. They then analyze them centimeter by centimeter, looking for telltale signs like chemical shifts, changes in particle size, or the presence of certain minerals. Sometimes, a simple change in color is enough to indicate a massive global event. The clues within these layers are not always dramatic. Often, they are incredibly subtle. It might be a slight uptick in a specific isotope, an unusual concentration of a rare element, or a carbon-13 to carbon-12 ratio that deviates from the established norm. While any one of these anomalies could have a natural explanation on its own, their combined appearance within a very thin slice of sediment points to something else. A sudden and significant event that disrupted the planet's long, steady rhythm. A perfect modern example is the Anthropocene, the proposed era defined by human impact, which is already imprinting its unique signature on the planet. Any future geologist studying our time will find a distinct layer marked by a spike in carbon dioxide, a sharp decline in biodiversity, and the presence of synthetic chemicals. This slender stratum in the Earth's crust will be unmistakable against the backdrop of previous eras, not a complete story, but a clear marker of a major disturbance. This is precisely the type of signal contemporary scientists are trained to identify. It stands to reason, then, that if a pre-human civilization had a similar environmental impact, it would leave behind a comparable signal. The real challenge, however, lies in properly interpreting it. For every potential sign of industry, a natural cause also exists. Volcanoes spew carbon, asteroid impacts can blanket the globe in rare metals, and even blooms of microbes can produce strange chemical residues. The planet itself possesses its own rich vocabulary for catastrophe, and it's remarkably easy to misinterpret the source of an anomaly if you assume every cause must be natural. This highlights the absolute importance of context. Discovering a lone chemical signature is simply not enough. Instead, you'd need a convergence of clues. Imagine finding a dramatic temperature spike that happens at the exact same time as a mass extinction event. Or perhaps a weird chemical compound shows up everywhere across the globe, not just in one isolated area. Picture a sudden surge in heavy metals appearing in the same layers as signs of burned fossil fuels. It's only by piecing together a puzzle like this that a suspicion of something beyond a natural disaster could even form. And even with all that, it remains a highly educated guess. The further back we peer into history, the less confident we can be in our conclusions. The most profound geological shifts happened eons ago, and their evidence has been warped by time, pulled apart, squeezed together, covered up, and then revealed again, sometimes multiple times. Although we see rock as permanent, it's constantly in flux. The messages it holds get garbled, entire chapters of stone vanish, and the record is never pristine. Even so, some messages refuse to be erased. Certain isotopes have such a slow rate of decay that they serve as reliable clocks over millions of years. We also see changes in the magnetic alignment of rock that correspond to predictable cycles in our planet's magnetic field, offering a sort of geological calendar. And some minerals can only be created under very precise circumstances, specific temperatures, intense pressures, or unique chemical soups. These are the bedrock vocabulary, the grammar of our planet's long history. Should a civilization have made a powerful and specific enough impact, traces of it might be recorded in this language. The real challenge, however, is being able to read it correctly. Researchers today still stumble upon baffling anomalies in the geological record, strange spikes or sudden shifts that don't line up with any known event. While most of these are eventually explained by natural processes, a few linger in scientific papers unresolved. They aren't ignored because they're insignificant. They're set aside because, without more evidence to connect them to, they're just isolated curiosities. Science thrives on patterns, not isolated data points. And this is precisely where a genuine clue to a past civilization could be hiding, right in front of us, but catalogued as a common natural occurrence. A signal that was too short, too weak, or too localized might not set off any red flags. Instead, it could easily be blamed on a massive volcanic eruption, a huge release of methane from the ocean floor, or a climate swing triggered by shifts in Earth's orbit. We know all of these things happen. They're regular parts of our planet's history. To suggest an intelligent source is behind such an event is an extraordinary claim that demands more than just strange data. It requires a compelling theoretical model that makes intelligence the most plausible explanation. Lacking that, a correct idea could easily be dismissed. This isn't a weakness of the scientific method. It's a vital safeguard against speculation and bias. But it does mean that some fascinating possibilities might never get the attention they deserve. The language of deep time is undoubtedly real, written in stone, chemicals, and the patient layering of sediment. It can tell us what happened, a general idea of when and frequently how it happened. What it can't tell us is why. Answering that question demands that we interpret, infer, and sometimes even imagine. And the idea of a lost civilization resides squarely in that realm of interpretation. Unconfirmed, perhaps forever so, but not entirely out of the question. If any clues do remain, they likely aren't the grand monuments or epic stories we might imagine. They would be the leftovers, the mundane scraps, the unintentional byproducts of existence. After all, if a civilization existed long before us, it probably wasn't trying to build a legacy for the ages. It was just trying to live. But the very act of living on a planet can alter it in profound ways, ways that might transform into baffling questions for a later species. We know some materials disappear almost overnight, like paper, fabric, and wood. Others, such as glass, metal, and concrete, stick around for a while. But a few things can outlast an entire civilization, not because they were designed for permanence, but simply because they are intrinsically resistant to the forces of decay. So, when considering the possible evidence of a long-lost civilization, our thinking must shift from what they might have built to what could possibly have survived. As it happens, that list is remarkably brief. The most durable fingerprint an industrial society can leave behind isn't found in its structures or machines, but in its chemistry. The acts of mining ores, creating new substances, burning fossil fuels, and changing the air itself all rewrite the planet's chemical composition. These alterations can be detected in the layers of sediment and soil, creating signatures that are tiny but global. When such a change happens suddenly all over the world, it leaves a very distinct mark in the geological record. A scientist billions of years from now might not understand what caused it, but they would be certain that something major took place. Take synthetic materials, for example. Our own civilization creates a huge range of substances that nature doesn't, from plastics and pesticides to industrial chemicals and specialized metal alloys. Many of these degrade rapidly with exposure to air and sun, but others prove to be incredibly resilient, particularly if they end up buried. Consider microplastics, which have already been discovered embedded in the planet's most isolated places, from the deepest ocean trenches to the snows of the Arctic. Research indicates that in the right environment, they might survive for tens or possibly even hundreds of thousands of years. Yet, plastics are not immortal. They break down when left on the surface, and while they might survive longer in an oxygen-deprived setting, they also become much more difficult to find. More importantly, finding a layer of unusual polymers isn't definitive proof of intelligence. It would certainly be puzzling, but without any other context or proof of manufacturing, it could easily be dismissed as a bizarre but natural geological formation, especially if no other evidence survived. Metal presents a similar challenge. While we often see it as a symbol of permanence, its durability is highly conditional. The vast majority of metals are susceptible to decay over long periods. Iron turns to rust, and copper develops a patina as it oxidizes. Even our famously corrosion-resistant stainless steel will eventually break down. In a perfect, dry setting, a metal object could potentially last for a few thousand years. But surviving for millions of years is almost out of the question. The only exception would be if an artifact was perfectly preserved in an incredibly stable location, like being entombed within a mountain. Even in that fantastically rare scenario, telling it apart from a natural vein of ore would be nearly impossible unless it had an unmistakably artificial shape or design. The case for radioactive isotopes is a bit more compelling. Certain isotopes are purely artificial, forged only inside nuclear reactions. Examples include plutonium-244 and other elements heavier than uranium that nature doesn't produce in any significant amount. Discovering a layer of these in ancient rock, far from any known source, would be a powerful indicator of advanced technology. The problem is that most of these man-made isotopes decay relatively quickly, fading into the background radiation over millions of years. However, a few, such as technetium-99 and iodine-129, have half-lives long enough that some residue might just survive if conditions were favorable. Another potential technosignature could come from burning fossil fuels. When we burn massive amounts of coal and oil, we release carbon dioxide that has a very specific isotopic fingerprint. Namely, it contains less of the heavier carbon-13 isotope compared to carbon-12. If geologists found a sudden, worldwide shift of this nature in ancient sediment layers, it would be a strong clue pointing toward industrial-scale burning. The catch, as always, is that nature can mimic this effect. Enormous volcanic eruptions or massive releases of methane can also produce similar isotopic patterns, meaning additional evidence would be essential to rule out natural causes. Far from being a keeper of secrets, the ocean is an agent of their destruction. It dismantles, disperses, entombs, and scours away any evidence. A society that thrived by the sea would likely have seen no danger, viewing water as a source of life, a bridge between lands, and a wellspring of sustenance, travel, and creativity. Yet, when we consider preservation across geological ages, the ocean is an unforgiving editor, wiping clean nearly everything it touches. For any civilization that left its mark below the waves, the probability of us finding that trace today is practically zero. Still, the question is worth exploring. If a technological society once engaged significantly with the marine world, what signature would it have left, and could that signature possibly endure deep time? Let's begin with a fundamental observation. The majority of our modern cities are situated on a coast, a practical choice offering access to commerce, resources, and temperate weather. This location, however, leaves them exposed. Shorelines are not static, storms erode them, sea levels fluctuate, and over geologic time, the oceans themselves shift dramatically. Just within the last 20,000 years, the sea has climbed more than 100 meters, inundating entire continental shelves. What is now deep underwater was once dry land during past ice ages, complete with flowing rivers and inhabitants. These former landscapes are now buried under thick deposits of sediment and brine, making them incredibly hard to reach and nearly impossible to explore in detail. Consequently, the hunt for any society that flourished on ancient shores is profoundly challenging. The difficulty is that their existence is unlikely, but that the very places they would have lived have been scoured, covered, or rendered unreachable. Underwater archaeology is tough enough. Attempting it on continental shelves hidden under post-ice age silt is a whole other level of difficulty. Imagine a bygone civilization had mastered maritime technologies, building not just vessels, but also harbors, ports, and perhaps extensive coastal facilities. How would such constructions fare across the expanse of deep time? In saltwater, wood rots, rope disintegrates, stone crumbles, and metal corrodes with surprising speed. The only hope for survival beyond a few millennia, let alone millions of years, would be rapid burial in an oxygen-poor environment of sand or silt. Even then, locating these remnants would be exceptionally difficult, requiring focused, high-resolution scanning technology. It's conceivable that man-made structures could leave behind geomorphological clues, like straight lines, odd angles, or recurring shapes in the topography of the seabed. The problem is that natural processes can also generate astonishingly geometric features. The vast majority of underwater oddities that have been examined have proven to be of natural origin. Proving an artificial source becomes nearly impossible when there is no surrounding context or associated artifacts. Now let's expand the scope of our thinking. Suppose a civilization didn't just live beside the ocean, but leveraged it on a massive scale for things like mining, energy production, or even waste dumping. Would such intensive use create a lasting signal? Our own species serves as a perfect example, having already imprinted a distinct geochemical signature on the seas. We see this in colossal floating patches of plastic garbage, in the mercury and lead-polluting deep-sea creatures, and in the radioactive elements scattered by mid-century nuclear tests. Chemical residues from our fertilizers create lifeless zones along coasts, while tiny plastic particles travel via currents and sea life to the deepest ocean trenches. A number of these markers could endure for tens of thousands of years, particularly if they become entombed in seafloor sediment. An earlier industrial society that released synthetic materials or transformed ocean chemistry on a similar grand scale might have left behind detectable, albeit faint, changes. However, discovering such a signal would be only half the battle. It would then need to be differentiated from the complex chemical fingerprints left by natural phenomena like volcanic activity, hydrothermal vents, and the decay of organic life. This entire problem boils down to what could be called the lost technology test. Can the evidence of an advanced civilization's activities actually persist in a form that remains readable after eons have passed? And even if it did, would we be able to identify its artificial origins, or would we simply label it another perplexing natural anomaly? As the timeline stretches back thousands of years, it is easy to feel small against the vastness of history. If you are enjoying this journey through time so far, comment the word ancient so I know you're still with me. This problem of misinterpretation becomes even more profound when we consider one of the most romanticized ideas of a lost civilization, the sunken city. The idea of cities lost beneath the waves often brings to mind legendary names like Atlantis or Lemuria, myths that have been passed down, partially remembered, and frequently reimagined in fiction. The reality, however, is that the ocean has been claiming actual cities for millennia, and none have left behind anything resembling a preserved monument beneath the sea. Far from preserving what it takes, the ocean systematically dismantles it. This process is slow but relentless, and after a few thousand years, let alone millions, what's left of a sunken city isn't ornate columns or tiled floors, but an overwhelming silence. Civilizations have historically been drawn to coastal areas, attracted by the fertile land, access to trade, and stable weather patterns that are so conducive to forming complex societies. However, establishing a city on the coast means building on a precarious line between stability and constant change, because shorelines are never static. They are in perpetual motion, shifting with tides, storms, earthquakes, and the vast, slow rhythm of glacial cycles, which cause sea levels to fluctuate and landmasses to rise or sink. A place that is dry land today could have been the ocean floor 50,000 years ago, just as an area of today's seabed might once have been a thriving settlement claimed by the advancing water. Take the site of Dwarka, off the Indian coast, which is frequently heralded as one of the most ancient submerged urban ruins. While some of its formations appear artificial, the site's true nature is contested, as erosion, marine life, and sediment have heavily altered the original materials. Similar examples include Pavloptry off the Greek coast or portions of the Doggerland region in the North Sea, once a populated landmass now lost to the waves. In every instance, the surviving traces are faint, fragmented, and extremely difficult to interpret. We have found these sites not because they were well preserved, but because they are relatively close to us, lie in shallow water, and disappeared in the recent past. If we look further into the past, the ocean's role transforms from burial to complete erasure. The seabed itself is perpetually being reshaped as currents shift sediment around, organisms colonize and alter every surface, and corrosion devours any exposed metal or concrete. A crucial factor is the constant addition of new layers of sediment. Anything that isn't covered quickly and deeply is inevitably broken down by a combination of chemical, mechanical, and biological forces. For this reason, submerged cities cease to resemble cities at all. Even stone constructions cannot endure the assault of saltwater, wave energy, and bioerosion. Over centuries, their corners are rounded, carvings fade away, mortar disintegrates, and all organic material vanishes, until the remnants simply merge with the surrounding geology. A fallen wall can be mistaken for an underwater ridge, while a collapsed building could look like a natural pile of rocks. This degree of degradation happens to cities that have been underwater for just a few thousand years. Now try to imagine a city that has been gone for 10 million years, even one with advanced architecture of towers and streets. The ocean would not have kept it intact. It would have ground it down, turned it over, and scattered its remains until they were utterly indistinguishable from the rubble on the seafloor. Then there is the problem of simple accessibility. The vast majority of the ocean floor remains completely unexplored. We possess more detailed maps of the moon than we do of our planet's own deep-sea terrain. Furthermore, when we do manage to survey these areas, the resolution is typically low. It is sufficient for identifying massive features like seamounts and trenches, but not for detecting smaller details, especially if they are buried or heavily decayed. While technologies like sonar, submersibles, and core sampling are useful, they are also slow, expensive, and limited in their reach. For anything to be found, it must either be exceptionally obvious or located in a place we already suspected. Otherwise, it remains hidden from view. But where the ocean actively dismantles the past, solid rock can sometimes act as a vault. While geology often erases, it also occasionally preserves, and within its layers, the planet might be holding on to something it shouldn't. The oddity isn't a grand structure or a written language, but a profound mystery, an object that seems to defy its own context. As we examine these anomalies more closely, they seem to suggest that our understanding of history is far from complete. Geologists read the Earth's history book page by page, layer by layer, searching for consistent narratives that explain the planet's condition at a given time. They look for clues about the climate, the presence of oceans or volcanoes, and the types of organisms that existed. Every stratum of rock is a snapshot, a data point written in minerals and dust. Yet every now and then they encounter something that doesn't belong, a word that feels out of place in the story. These are geological anomalies. While scientific investigation eventually provides a rational explanation for most, a few continue to puzzle us from the margins, awaiting new perspectives or technologies to decode them. Not every anomaly is a deep mystery. Geology is filled with strange yet entirely natural occurrences, from unusual mineral inclusions to bizarre fossil shapes and intricate layering created by sudden environmental changes. Once in a while, however, an item appears that seems to defy a natural origin. It might be a fragment that looks manufactured, a chemical makeup that clashes with its rocky surroundings, or an object so regular and deliberate in its shape that it appears artificial. Consider the tales that emerged from coal mines during the 19th and early 20th centuries. Reports surfaced of miners discovering metallic objects, like chains, bells, or intricately carved stones, lodged deep inside solid lumps of coal. These accounts were typically documented poorly, with almost no surviving specimens and no reliable information about their origins. Skeptics have valid points. noting that mining is a chaotic process where coal seams can fracture and mix with modern debris. Confirmation bias likely played a role as well, with people finding what they hoped to find. Still, these stories endure not as proof of anything, but as a reflection of the kinds of signals we instinctively search for. Another example involves the metallic spheres discovered in South African mines, which are often presented by fringe theorists as evidence of ancient technology. These small, grooved orbs were found embedded in Precambrian rock dated at over 2 billion years old. However, scientific analysis concluded they are almost certainly natural concretions, which form as minerals accumulate under intense pressure. The grooves are thought to be the result of natural deformation processes. While fascinating, they are not manufactured. Anomalies like these tend to exist on the periphery of scientific focus. Some are never properly studied due to a lack of context. Others are set aside because the burden of proof required for such an extraordinary claim is, quite rightly, extremely high. The vast majority are eventually explained away with more time, better samples, or new data. Yet a handful remain in the unexplained file, not proven to be artificial, but simply unresolved. This reveals a key aspect of scientific inquiry. It is inherently cautious. It doesn't jump to conclusions, but instead favors known natural processes over unknown ones. Science demands evidence that can be repeatedly verified, not isolated curiosities. Consequently, when a strange object is found in ancient rock, a standard set of questions must be answered first. Could this have formed naturally? Is there any contamination? Was the rock layer disturbed? Has the finding been confirmed with multiple independent methods? The anomaly remains in limbo unless the answers to all these questions are definitive. But the search for misplaced clues isn't limited to physical objects. Sometimes the most profound mysteries are written in chemistry. Isotope excursions, for example, represent sudden, worldwide shifts in the ratios of elements like carbon and oxygen. These events appear in the geological record as sharp deviations in geochemistry. Most are attributed to known causes, such as colossal volcanic eruptions, massive methane releases, or the impact of an asteroid. Even so, the precise mechanisms behind them are not always perfectly understood. Certain events correspond with periods of rapid warming, ocean acidification, and mass extinction, all concentrated within a remarkably thin slice of rock. Some researchers have drawn comparisons between these ancient events and our own industrial output, raising the quiet question of whether similar ancient patterns might hint at intelligence. The standard answer is no. This isn't because it is impossible, but because it's an unnecessary leap. Most geological events don't require intelligence as an explanation. Imagine, however, an anomaly that defies all known natural explanations. Consider a specific layer with precise industrial chemical signatures, synthetic molecules, unique isotope ratios, or rare metals spread globally without a volcanic or cosmic source. Such a finding would be hard to dismiss. We haven't found one yet, though it's possible the data exists in a database, filed as an oddity, awaiting a new kind of question. We should also recall that many breakthroughs don't come from direct searches, but from noticing something odd and investigating it. Plate tectonics and the dinosaur extinction asteroid were once fringe concepts. For both, the evidence existed for decades before someone connected the pieces. Anomalies only become significant when someone pauses to consider their alternative meanings. This brings us back to lost civilizations. Any potential traces would likely be subtle, not spectacular artifacts or carvings. They might be an odd mineral deposit, a strange metallic distribution, or a synthetic molecule in ancient rock. Individually, these clues mean little, but together they could suggest technology. We might have already found such evidence, but interpreted it through our existing biases. A geologic pattern viewed as weathering, a structure dismissed as a fluke, or a chemical spike blamed on a methane release. In most cases, that interpretation is probably correct. But what if, just once in a while, it's not? The truth is, we have no idea how a civilization from deep time would appear in stone, nor how long its signs would endure. We only know what kinds of things persist. Any faint signal would have to exist within these durable remnants, the anomalies, chemical traces, and perplexing patterns. So the search continues, not for a buried city, but for a quiet possibility. The message, if there is one, would be layered deep in the rock, written not in language, but in raw data, an accidental legacy. Let's now shift from the geological record to a different archive, one preserved not in stone, but in stories. History does not always vanish, sometimes it reverberates. The boundary separating real memory from myth is often surprisingly thin. When artifacts and rock layers offer no more clues, we are left with stories. These are not scientific data but myths, oral traditions handed down through generations. Though details change and meanings blur over time, the core narratives persist. Myths possess a unique resilience, surviving even the collapse of civilizations and the death of languages. Though seldom seen as literal history, there's a growing view that myths might contain fragments of actual events, coded and warped, but not purely fictional. The concept is not new. Societies worldwide have tales of great floods, of fire, of falling stars, and of lands that vanished. Their legends describe golden ages ending abruptly, lost wisdom, periods of darkness, strange visitors, and islands consumed by the sea. Individually, these tales seem symbolic. Collectively, however, they form patterns that suggest shared experiences or even shared memories of events that predate writing itself. The Great Flood is one of the most persistent themes, appearing in Sumerian, Babylonian, Greek, Hindu, Norse, and biblical traditions. While specific details change, the core story is consistent. A massive deluge destroys a prior world, often as judgment or renewal. In these narratives, a few survivors are typically warned beforehand, prompting them to build boats or seek safety on mountains. It's easy to dismiss these accounts as metaphors for seasonal rains or human fragility. However, geology confirms a period of dramatic sea level rise and coastal flooding at the end of the last ice age. Melting glaciers caused oceans to climb over 100 meters, drowning entire landscapes. Coastal populations would have seen their world vanish, and their descendants could have passed down stories about it. Other myths tell of lost lands like Atlantis, Mu, or Cumaricandum. These places are consistently depicted as advanced, beautiful, and doomed. The cause may be pride, war, or divine wrath, but the ending is always the same. The land sinks and only the legend survives. Today, these stories are mostly seen as fiction, inspired by allegory or folklore. But even fiction can hold echoes. A memory of a submerged land could be real, despite the details. There are also recurring tales of lost knowledge. Many traditions describe a time when people knew more, when wisdom was common and the stars were understood. While not proof, these ideas raise a question. What causes a culture to believe it has forgotten more than it knows? A powerful question, and while not every culture sees its past this way, many traditions do. These cultures often tell stories of a great fall, which wasn't just a moral collapse but an intellectual one, a catastrophic loss of knowledge, skill, and a vital connection to something greater. You can even find strange anomalies embedded in ancient texts, with tales of sophisticated machines, vehicles that soared through the air, cities floating in the clouds, and weaponry of unnatural destructive power. While in most instances these are clearly symbolic or allegorical, there are moments when the descriptions become strangely exact. Some would argue they are too specific to have been born from pure imagination. Those who defend the idea of myth as a form of memory believe these could be garbled recollections of actual things. They might be descriptions of technologies or historical events that were handed down through oral tradition for so long that the original context was completely forgotten. This is an incredibly difficult position to verify through scientific means. Myths simply aren't evidence, they aren't dated, and they don't arrive with calibration marks or any useful geological context. Yet they are an undeniable part of the human record, and it's worth asking why so many different cultures, with no obvious lines of contact, happen to tell such similar stories. This question is now being revisited by modern scholars in fields like anthropology and archaeology. Their goal isn't to find ancient astronauts or long-lost continents, but to gain a deeper understanding of how oral history actually functions, the ways in which stories are kept, changed, and transmitted across generations. Within certain indigenous traditions, oral histories have been shown to be astonishingly precise when compared against archaeological findings or environmental data. Whole landscapes, the ancient paths of rivers, the retreat of glaciers, and even volcanic eruptions have been chronicled in stories centuries before the existence of any written accounts. This proves that myths are not just idle fantasy. They are a form of compressed history, molded by language and culture, but fundamentally grounded in real experience. They may be filled with metaphors, certainly, but these are often metaphors for something tangible. With enough patience, it's sometimes possible to decode what those metaphors refer to. None of this is proof that an earlier industrial civilization existed. It does, however, make the notion that history only began with the invention of writing far more complicated. A lack of a written script does not mean a culture had no memory. In a world where physical evidence is incredibly fragile, but a good story can survive for millennia, perhaps our myths are deserving of a second glance. They might not tell us exactly what transpired, but they could be telling us that something happened, something important enough that people tried to preserve it using the only medium they had. This line of thinking eventually leads us away from stories and toward the ground itself, to the literal bits and pieces we've pulled from the earth that occasionally seem out of place. We shift from metaphors to materials, to objects with definite shape, weight, and texture. Some are ordinary, some are strange, and a few raise just enough questions to keep this enduring idea alive. Consider Tectites. These are small, glassy objects, typically dark in color and aerodynamic in form, that are found scattered across specific regions of the planet with a remarkably consistent composition. The consensus among geologists is that they are the result of major impact events. When a meteorite strikes the Earth, it melts the local rock and flings droplets of this molten material high into the atmosphere, where they cool and rain back down. They are certainly fascinating, but not inherently mysterious, at least when viewed in isolation. The story gets more interesting when you notice how often these strange little objects, tectites, fragments of metal, or unusually shaped stones, get woven into narratives that go far beyond geology. These are stories of lost technologies, vanished builders, and tools found where no tools should be. And although the vast majority of these claims fail to withstand scientific scrutiny, some of the artifacts at their center are quite real. They aren't alien or magical, they're just very difficult to classify. They often end up sitting in museum drawers, either misfiled or simply unstudied. This isn't because of a conspiracy or neglect, but because science tends to move on when an object doesn't fit neatly into an existing framework. This brings us to the so-called out-of-place artifacts, a term often shortened to OOP-arts. These are defined as objects discovered within geological layers that predate the known timeline of human history. Famous examples include claims of metal spheres found in billion-year-old rock, carved objects pulled from seams of coal, or items that look machined embedded in solid stone. Nearly all of these have been explained away as hoaxes, misidentifications, or unusual natural formations. But the persistence of these tales tells us something important, not necessarily about ancient machines, but about the deep human hunger for a different story of our past. One where civilization didn't just begin 10,000 years ago, but has risen and fallen for a much longer time. Sometimes these artifacts are truly puzzling. A polished stone ball exhibiting perfect symmetry, a copper tool found in a stratum thought to be too old for metallurgy, a carved pattern discovered deep within a cave no known culture was believed to have ever reached. In almost every single case, there are natural, or at least plausible, explanations. Geology is capable of creating surprisingly regular shapes. Chemical weathering can etch rock in bizarre patterns, and artifacts can be displaced through layers by animal burrows, shifts in groundwater, or simple human error during an excavation. But even if none of these objects is ever the definitive proof of a lost civilization, their existence highlights a crucial point. The further back in time you look, the more difficult it is to prove or disprove anything. Sediment gets mixed up. Caves collapse. Our dating methods depend entirely on context, and context is very easily lost. If a technological object were discovered in a layer 10 million years old and it didn't match anything we recognized, our first conclusion would not be that the object was ancient. We would almost certainly assume it was contamination, a misplaced sample, or a modern item that somehow worked its way down. And the vast majority of the time, that conclusion would be correct. However, that assumption, while statistically sound, effectively renders us blind to the incredibly rare possibility that it might be wrong. Real tools are capable of surviving for an immense amount of time under the right conditions. Stone tools, especially, are remarkably resilient. We have found chipped flints that are over 2 million years old, showing clear signs of deliberate shaping, use wear, and evidence of learned techniques being passed down. What's significant here is that it took archaeology a very long time to even recognize some of the earliest artifacts as tools. For years, many were written off as geofacts, stones that were broken naturally. It was only when clear patterns began to emerge, repetition in shape, clustering in specific locations, and consistent wear marks, that the scientific community started to accept their human origin. This provides a direct lesson for the search for any non-human predecessor. The first signs would not be cities or complex machines. They would be subtle patterns, tools that don't match the local geology, or arrangements of materials that hint at deliberate planning. These would be regular shapes that appear more frequently than chance alone would permit. Such signs would be exceptionally easy to miss, particularly when their context is gone. And context is always fragile. Imagine discovering a perfectly formed sphere in a rock layer dated to 100 million years ago. The immediate assumption would be that the layer was disturbed and the object is intrusive, and that could very well be true. But if we automatically dismiss every single anomaly that doesn't conform to our known timeline, we are actively closing the door on any discovery that might change that timeline. Then you have the tall tales, the stories passed around or published in fringe journals about impossible discoveries. An iron nail in a block of sandstone, a mechanical-looking device in a lump of coal, or a human footprint alongside a trilobite. These claims nearly always disintegrate upon investigation, revealing poor documentation, a missing sample, or evidence of tampering. But not all are deliberate hoaxes. Some originate from well-intentioned observers who lack the background or tools to correctly interpret what they had found. And many are just simple mistakes, where a natural feature looked artificial in the moment. And yet, the core idea behind these stories, that something came before us, isn't inherently incorrect. What's usually flawed is the specific evidence being presented, but the motivation for looking is understandable. People want to believe that history is deeper than we've been told, and that our own story might just be one chapter in a much, much longer book. But what if the other chapters in that book were written in a language we just don't recognize? Our entire picture of civilization is framed by certain expectations. We look for buildings, for machines, for writing, and for monuments. The common thread running through nearly all of it is metal. It's so fundamental to our thinking that we've named our historical epochs after it: the Stone Age, the Bronze Age, the Iron Age. This progression feels so natural to us, like a single ladder that every intelligent species must climb. We often forget that this is just our asterisk path, and that true intelligence doesn't need metal to flourish. So let's entertain a thought experiment. What would happen if a civilization evolved, thrived, and eventually vanished, all without ever hammering a single piece of metal out of a rock? This idea isn't as strange as it sounds. Our own species spent the vast majority of its history living this way. Early humans used fire, built shelters from wood and bone, and crafted intricate stone tools. They understood complex animal behaviors, made clothing to survive the elements, decorated their living spaces, and passed down generations of knowledge through rich oral traditions, all before the first smelter was ever fired up. In fact, many indigenous cultures have continued to prosper with little or no reliance on metallurgy. Complexity, it turns out, doesn't start with forging iron. That's just when it becomes easier for future archaeologists to spot. If we imagine a non-human or pre-human civilization, it's critical to ask what their archaeological footprint would look like if they never entered a metal age. The simple answer is that it would be almost invisible. Anything made of organic materials, wood, plant fibers, animal hides, even bone, decomposes with alarming speed. Unless an artifact is trapped in an environment that is perfectly dry, frozen, or completely without oxygen, it will disappear. Textiles unravel into soil. Wood is eaten by microbes or consumed by fire. Everything left exposed to the elements is broken down and reclaimed by nature. Without the stubborn permanence of stone, ceramic, or metal to anchor their memory, the objects of a culture simply vanish. Even when these organic remains do survive, we rarely identify them as technology unless they show obvious signs of being carved or shaped. Is a bundle of fibers a piece of ancient rope, or just a tangle of tree roots? Is a hollowed-out log a prehistoric canoe, or just the work of decay? Picture a hypothetical society that built its entire world from things that grow. Their homes could be woven from resilient plant fibers. Their tools could be carved from dense hardwoods, and their containers fashioned from gourds or stretched leather. All of their art, their clothing, and even their written symbols could be made with pigments from berries and clay, or with decorative feathers, bark, and sand. With nothing ever mined or smelted, there would be no durable fragments left to rust or shatter over millennia. In a favorable climate, a society like this could thrive for thousands of years, and yet its passing would leave almost nothing for the geological record to hold onto. A forest would swallow its settlements in a single decade. Erosion would carry away the rest. 1,000,000 years later, not a single trace would remain. Even fire, one of humanity's oldest and most powerful technologies, leaves an ambiguous legacy. You might find layers of charcoal, beds of ash, or rocks cracked by intense heat, but nature produces these signs all the time through lightning strikes, forest fires, and volcanic eruptions. To know if a fire was started by an intelligent being, you need context. You need to find the structured remains of a hearth, deliberate patterns in the burn, or other artifacts nearby. Without that context, it's just another black smudge in the layers of dirt. Of course, some stone tools could survive, but we have a narrow idea of what a tool looks like. A simple, unshaped river stone used for grinding grain or softening animal hide might never be recognized for what it was. A sharp-edged rock used once for cutting and then discarded might lack the telltale marks of being retouched. If tools weren't carefully kept, stored, and reused, they would simply blend back into the natural landscape of rocks and pebbles from which they came. They become functionally invisible. It's also entirely possible for a culture to achieve profound scientific understanding in fields like astronomy, agriculture, and even medicine, without ever building heavy industry. Knowledge isn't always bound to physical objects. A society could map the constellations with naked-eye observation, track the changing seasons with precise wooden markers, or breed new strains of plants through centuries of careful selection. They could tell time with flowing water, perform complex calculations with knotted strings, or encode entire libraries of information into epic songs. None of these systems require a single ounce of metal, only the unbroken continuity of culture. But if that chain is broken by a disaster, a disease, or a migration, the knowledge can be lost just as completely as the tools decay. Language itself is a ghost. Spoken words fade the moment they are uttered, and unless a culture develops a durable form of writing, its voice is lost to time forever. Then there is the matter of scale. Our bias is to define advanced civilizations by their massive footprints, by their sprawling cities, their industrial pollution, and their enormous energy consumption. We assume all intelligent life builds big, but these are cultural choices, not laws of nature. A society could be technologically brilliant and philosophically deep, yet consciously choose to live in a way that minimizes its impact on the planet. Perhaps they learned from past mistakes that high-impact living inevitably leads to collapse. In that case, what subtle clues would they leave behind? We might find landscapes that have been gently modified, hillsides carved into ancient terraces, rivers with unnaturally smooth curves, or plant species flourishing thousands of miles from their point of origin. We might find faint chemical traces of sophisticated fire management or soils that have been deliberately enriched. But these signs are incredibly easy to misinterpret as natural formations. We can see this very dynamic in our own world with the Amazon's terripreta, a dark, incredibly fertile soil created by ancient communities. This soil is filled with charcoal, bone, and pottery shards, layered in a way that strongly suggests intentional, large-scale engineering. It's the legacy of a complex, organized society with profound agricultural knowledge. But it doesn't look like a city, it looks like dirt. For a long time, that's exactly what it was dismissed as. Now imagine if something similar happened 100 million years ago, with fewer pieces of pottery and in a place that has since been swallowed by the ocean or ground up by tectonic plates. It would never be found. So a civilization without metal might be lost to us not because it failed, but because it succeeded in a way we don't often consider. It succeeded in living lightly, in weaving itself into the environment, and in valuing natural cycles over permanent monuments. From an archaeological perspective, that kind of success looks exactly like absence. We are conditioned to think of progress as a trail of artifacts left in our wake. But sometimes, the absence of that trail isn't proof of nothing. It's the quiet evidence of a different choice, or simply the final victory of time, which never promised to keep our records for us. The ground beneath our feet is a library of memory, though its whispers are faint. Within the soil are the recollections of everything that grew and died, everything that burned or simply passed by. Footprints are sometimes captured, while blood, ash, rain, and the remnants of decay are all absorbed. History isn't proclaimed from the earth. Instead, it is held tightly, silently, and offered up only in fragments. With the right approach, a story can sometimes be coaxed from these layers, but far more common is the discovery of nothing at all. It is in this profound quiet that the true fragility of any civilization's legacy becomes terrifyingly clear. We tend to perceive soil merely as a surface, yet it functions more like a dynamic interface, the crucial meeting point between the living world and the inanimate one. This is the very nexus where biology and geology collide. The ground we walk on is constantly being shaped by the fall of every leaf, the death of every creature, and the push of every root. With enough time, these accumulated layers undergo compaction, eventually fading into sediment. If subjected to enough pressure and depth, they can even transform into solid rock. The problem is that most soil doesn't stick around long enough for this transformation. It gets churned, eroded, and carried away, making the traces that manage to survive exceptionally rare. Certainly, some places retain a clear signal of previous life. You can find the char left by ancient hearths or the organic stains from where a home once collapsed. Burial sites betray themselves through patterns of disturbed earth, discoloration, and chemical signatures. But these signs are incredibly delicate. Just a few millennia of weather or agricultural activity can wipe them away. Over geological timescales, they stand little chance unless perfectly preserved in an unusually stable place like frozen tundra or an arid desert. This is a key reason our knowledge of ancient civilizations comes primarily from stone and metal. The data held in the soil simply doesn't last, and once stripped of context, separated from artifacts or clear geological layering, it ceases to be a coherent story. It becomes random noise, or worse, nothing. Even so, modern researchers are devising clever methods to listen to that silence. Archaeobotany, for instance, analyzes microscopic plant remains like pollen grains to reconstruct entire ancient landscapes. Meanwhile, geoarchaeologists examine soil chemistry and structure to deduce human activity. A layer of blackened earth could hint at controlled fires. A high concentration of phosphates might indicate a settlement. Patches of unusually rich soil could even point to sustained agriculture. Yet every one of these clues is ambiguous. Those phosphates might have come from a herd of animals, not a village. That dark soil could be from a lightning strike, not a hearth. Soil enriched with charcoal might be a deliberate creation like Amazonian terra preta, or it could be the aftermath of a forest fire. Unless these traces appear in repeated, deliberate patterns, they can't be distinguished from the background noise of the natural world. This fundamental uncertainty is what we collide with when asking if another civilization might have existed in the deep past. The soil itself will never provide a definitive answer. Not on its own, and certainly not after millions of years. Even if such a society once transformed the landscape, those alterations would have been almost completely reabsorbed into the geological matrix. The evidence would have been turned over, washed away, or simply erased. It's a challenging concept that an entire society could vanish so thoroughly that the very ground it occupied forgets its existence. But this isn't a cruel act of nature, it's simply the indifference of time. If a record isn't made of something that can resist, then nothing will remain. And soil, as a medium, offers very little resistance. It is a collaborator in the great cycle of decay and renewal. And there's an even deeper problem. Supposing a few traces did manage to survive, how could we ever be certain they weren't natural? What would distinguish an ancient, cultivated garden from a wild meadow, or a deliberate fire pit from a random patch of scorched earth? The further back in time we look, the less these distinctions mean. At a certain point, intentional action becomes indistinguishable from a geological accident. We must also confront the fact that what lasts is not necessarily what was most important. Stories do not fossilize. Human relationships don't appear in core samples. The ideas, songs, and rituals that define a culture leave behind no chemical signature. Even when physical objects are found, their meaning is often lost. We have discovered ancient tools whose purpose we still don't understand and symbols from known civilizations that we are unable to decode. The interpretive gap for a completely unknown culture would be infinitely wider. So when we turn to the soil for answers, we must be honest about what a meaningful signal would even look like. Is a strange spike in a chemical reading or a layer of charcoal in an odd place evidence of intelligence, or is it just static? In the vastness of deep time, that line is almost invisible. But perhaps the silence is its own kind of message. It tells us that even consciousness and culture can pass through this world without leaving a mark. It suggests the Earth makes no distinction between life that shapes itself through instinct and life that does so through thought. Unless a civilization produces something durable, strange, and undeniably artificial, it will be lost to the great cycle, becoming just another forgotten layer, another anonymous shade in the soil. The truest test of our existence, then, isn't found in our bustling present, but in the permanent marks we are etching into the planet's geology. These are the marks that would need no interpreter to be noticed. If some future intelligence, human or otherwise, were to sift through the strata we are now creating, what clues would they actually discover? Certain indicators would be impossible to miss. Our impact on atmospheric chemistry is already being recorded in polar ice and seafloor mud. We are causing a surge in carbon dioxide at a speed not seen for millions of years, while methane levels climb and the planet's nitrogen cycle is bent out of shape by our agricultural fertilizers. These shifts are happening everywhere at once, creating a sudden, jarring anomaly in Earth's otherwise steady climatic history. Any geologist of the distant future, regardless of their origin, would recognize this sharp, planetary-wide spike and conclude that a major event defined our era. Our synthetic polymers offer another clear giveaway. Plastic is now settling in nearly every corner of the globe, from the deepest ocean trenches to the highest mountain peaks, filling landfills and choking rivers. Tiny fragments, or microplastics, are embedding themselves in seafloor sediment and working their way into the food chain. Because these materials resist decomposition, their chemical signatures could persist long after they've crumbled into dust. A future scientist might discover a thin, globally distributed layer of sediment laced with these artificial particles. This stratum would be remarkable not for its permanence, but for its sheer artificiality, a unique marker of substances the Earth itself never conceived. Beyond plastics, we are subtly rewriting the planet's mineralogy. Our industrial activities give rise to materials the world has never seen, from the fly ash of burnt coal and the slag of smelted metals to concrete dust and artificial alloys. These technofossils are being created in real time, frequently sealed within our concrete structures or interred in our waste dumps. Millennia from now, they could appear as strange, angular flecks within newly formed rock, betraying their artificial origins through unique elemental combinations that nature itself would never produce. An even more potent signal is the radioactive fallout from our past. The atmospheric nuclear tests of the mid-1900s blanketed the entire planet with specific isotopes like cesium-137 and plutonium-239. While these elements decay predictably, their presence is still detectable in everything from the soil to the skeletons of wildlife. This brief, intense pulse of radioactivity could remain a measurable signature for tens of thousands of years. For any future observer, it would register as a perplexing, instantaneous flash of radiation without any known cosmic or geological source. Ironically, the most visible symbols of our civilization, our sprawling cities, would be among the first to go. Within a few centuries, rust, water, and plant life would tear our buildings apart, leaving them as unrecognizable ruins. In 10,000 years, you'd need a dedicated excavation to even find a trace. Only structures quickly entombed by a volcano or a flood might be preserved, and even they would likely become a chaotic jumble of rubble. However, our subterranean constructions like subway tunnels and bunkers could endure for much longer. Future explorers might uncover these unnaturally precise voids, but without context, their meaning would be a mystery. An underground data center could easily be mistaken for a strange cave. The complex machinery that defines our era, from cars and planes to smartphones, is also destined for rapid decay. Metals will corrode and plastics will crumble, leaving behind only fossilized fragments like an engine block. Our technology was built for immediate function, not for geological permanence. The information we create is even more ephemeral. Magnetic and optical storage media degrade relatively quickly, and our entire digital world, our art, science, and history, could simply evaporate. Our information age might become a complete void in the geological record, a silent gap defined only by the chemical chaos that surrounded it. Our agricultural practices could leave more enduring traces. The planet-wide transformation of ecosystems has fundamentally altered soil chemistry and erosion patterns. In the distant future, analysis of fossilized pollen might reveal a bizarre, sudden takeover by just a handful of plant species, hinting at widespread cultivation. Similarly, the bones of our domesticated animals, genetically distinct from their wild cousins, could be found in dense concentrations near old settlements. If buried quickly, these remains could tell a partial story for tens of thousands of years, a planet of farms with no farmers. The burning of fossil fuels provides another powerful signal. Our massive consumption of coal, oil, and gas is leaving a unique isotopic fingerprint in the air, water, and soil. When compressed into a future layer of rock, this signature will appear as an abrupt, dramatic shift. It will be the geological marker of a planet thrown into disarray, a story of soaring greenhouse gases, rising temperatures, and acidifying oceans unlike anything in Earth's deep past. In the end, what is our true, lasting legacy? It won't be our monuments or our stories. It will be our chemistry, a specific ratio of isotopes, a collection of synthetic molecules, and a scattering of bizarre minerals. Our mark will be a sudden spike in atmospheric carbon, a corresponding plunge in biological diversity, and an unmistakable line etched into the planet's stone. This signature, sharp, swift, and worldwide, would be undeniable proof that an intelligent, industrial species was here. It would tell a tale of a civilization that built, burned, and ultimately entombed itself within its own geological record. For any observer millions of years in the future, that single line might be all they have. It would not be enough to understand who we were, but it would be enough to know that we were here, and to be left wondering what became of us. So what did become of them? The most straightforward answer to why we find no institutions preserving ancient knowledge or clear signs of intelligent intervention in the evolutionary record is simply the immense scale of time involved. Consider our own timeline for perspective. Our entire civilization is only a few thousand years old, with agriculture dating back a mere 12,000. Our industrial age is just 200 years young, and the digital era has existed for only a few decades. Yet in that sliver of existence, we have managed to reshape the entire planet. Now imagine transposing a civilization of a similar duration, say 10 or 20,000 years, onto a canvas painted 50 million years in the past. What evidence would remain? At most, a few unusual layers in the geological sediment. Their influence would likely blend invisibly into the natural record, unless they undertook planet-altering projects like seeding new life or fundamentally changing the genome of existing species. We tend to view intelligence as a force that inevitably accumulates, building upon itself and growing in complexity toward predictable outcomes, but this is merely our own projection. Evolution has no stake in continuity. An entire species can be wiped out in a single generation, and a culture can crumble in just a few seasons. Complexity, it turns out, is no protection against extinction. There is no guarantee that an intelligence, once lost, will ever get a second chance. Their end could have been abrupt: a devastating war, a catastrophic climate event, a technological mishap, or even just the slow, grinding attrition of stability as soils were depleted. Species were lost, and their systems grew too interconnected to adapt. In the event of such a collapse, their population might have plummeted, its remnants scattering, regressing, and ultimately vanishing. With no one left to safeguard their legacy, their knowledge would fade, their language would unravel, and their stories would fragment into oblivion. Alternatively, they might have simply left, not by voyaging to the stars, but by retreating into silence and minimalism. It's possible they embraced a way of life that deliberately ceased its outward growth, recognizing that expansion has its limits. Perhaps they opted not to construct grand monuments, but to blend seamlessly with their environment. Over generations, they could have faded from the physical world without disaster or regret, not a fall from grace, but a conscious letting go. In that scenario, they might have erased themselves from history so cleanly that we could never prove they were here. There's also the unsettling idea that they just didn't exist long enough to leave a story. Intelligence could have flared up briefly, like a spark that never catches, failing to reach a critical mass before being extinguished. In a world teeming with predators, natural disasters, and biological risks, a species might achieve consciousness without developing culture, or culture without building a civilization, or a civilization without the resilience to endure. Of course, asking where they went requires us to first ask what we are assuming about they. Were they like us, bipedal, tool-using, language-speaking primates who build machines? Or were they something far stranger, like a collective of octopus minds, a network intelligence dwelling in trees, or a vast oceanic consciousness? Intelligence does not have to manifest in forms we recognize, and if it emerged in a way that doesn't leave the kinds of traces we look for, then we might be asking the wrong question entirely. The question shouldn't be, where did they go? But rather, what were they to begin with? Recognizing any mark they might have left would demand that we step far outside our human-centric assumptions. We would need to search not for artifacts and ruins, but for absences and disruptions. We'd have to be open to discovering traces not just in rock and metal, but hidden in genes, sediments, and isotopic ratios, patterns that don't align with natural processes but don't scream machine either. Perhaps they didn't go anywhere at all. Maybe their entire existence was simply folded back into the biosphere, recycled into dust, genetic code, and cellular life. It's conceivable we've already dug through the foundations of their cities without a clue that the silicon in our microchips was once the material of their homes. Their legacy might not be gone, but merely scrambled, diluted, and repurposed by the relentless metabolism of the Earth. Or in some form they could still be here, not biologically or consciously, but embedded in the very systems they altered. Their remnants could be the reshaped ecosystems, redirected rivers, and modified genomes we see today, structures too ancient to be labeled, too strange to be claimed, and too ambiguous to be remembered, no longer recognizing us as their audience. The deeper we dig, the more we realize that disappearance, especially on a planet like this, can be absolute. Our attention is naturally drawn to the obvious anomaly, the sharp edge in an otherwise uniform stratum. Anything that blends in, however, tends to be overlooked and fade from view. This very tendency makes investigating a potential pre-human civilization so challenging. The difficulty isn't that the concept is ridiculous. It's that it occupies a realm where the evidence is most faint and our interpretations are most flexible. For scientists, it demands a delicate balance, welcoming doubt while maintaining strict discipline and acknowledging the unknown without resorting to fanciful speculation. The resistance from most of the scientific community doesn't stem from hubris but from methodical training. The foundational principle is that exceptional claims must be supported by exceptional proof, and to date, none has been found. We have found no gears embedded in Permian strata, no encoded information within layers of carbon, nor any artifact or signal that could only be explained by intelligence and not by natural processes. Yet the lack of such proof is not definitive proof of their non-existence. Across vast timescales, silence can become the most prominent characteristic, not because a period was empty, but because our planet is exceptionally effective at erasing its own past. This realization brings us back to a place of humility, not as an admission of defeat, but as a commitment to intellectual honesty. We simply cannot be certain if we are the first. It's possible we will never know for sure. Even if another civilization existed, the evidence may be lost forever, or if we do stumble upon it, we might fail to understand its true nature. Today, while we chart geological oddities, analyze mass extinctions, and follow chemical trails in sediment, our search is constrained by our own expectations. We know what to do with the discovery of a buried city because it fits our model. A sudden increase in iridium or carbon could be an asteroid impact or a global fire. It requires a significant mental leap to identify a pattern that doesn't conform to a pre-existing template. This is not just a scientific constraint, it's also a cultural and emotional one. Accepting that a civilization like ours could have risen and vanished completely would fundamentally alter our assumptions about what is inevitable. Our concept of progress would seem far more delicate. The lifespan of a civilization would appear fleeting. Intelligence itself would feel less like an ultimate achievement and more like a random opportunity, something that could appear, disappear, and perhaps reappear, or maybe not at all. Beyond the evidence, there is the profound question of what it would all mean. How would it affect us now to know that others came before, beings who also constructed, imagined, questioned, and ultimately failed? Would such a discovery diminish our own significance, or would it foster a deeper sense of connection to a larger story? Are we doomed to relive their errors, or are we forging a completely different destiny? We have no answers, and perhaps embracing that uncertainty is central to the entire exercise. It could be that the most enduring inheritance from a predecessor isn't physical, but is instead purely an idea. The legacy is the mere possibility of their existence, the thought that we may not be unique, and the realization that a future intelligence might one day ponder the same questions about our own time. When they look back at our layer, what will they find? A surge of carbon, a thin layer of plastic, a momentary flicker in the rock. Would they define it as a civilization, a catastrophe, or simply as evidence that they were not the first? We tend to think of the past as a static, unchangeable record. In reality, it is fluid, changing its shape each time we examine it with new perspectives or inquiries. This inquiry into lost worlds, then, is not truly a historical one. It is a measure of our own capacity to coexist with uncertainty and to permit a sense of wonder to influence our understanding of the universe. Not all enigmas require a neat resolution. Some simply need to be recognized. This particular mystery, perhaps more than any other, doesn't ask for our faith, but for our focus. After all the investigation and the journey through geological time, we find ourselves on the quiet precipice of the question. We are left with a sense of stillness instead of certainty. Within that calm, the question itself seems to lose its sharp edge, not because we have solved it, but simply because we have truly listened to it. It's possible we are the first, and it's possible we are not. Perhaps intelligence is an exceptionally rare phenomenon. Or maybe it's just elusive, flowering in secluded places only to vanish without a trace. The Earth might have been home to more consciousnesses than we can ever imagine, each one sparking into being, influencing its epoch, and then silently disappearing under the weight of the next. In the end, we seek answers because that is the fundamental nature of a curious mind. This impulse is not simply to find, but to stretch our reach across possibility and time itself. It is the same instinct that launches machines to distant planets that also sends our minds into the deep past, wondering who else might have stood right here, looking up, listening. You, in this very moment, are a part of that tradition, a thread connecting the question to the quiet and the quiet to the story. By simply following this path of thought, you participate in an act that is profoundly human, or maybe even universal to all consciousness. Sleep can be seen as its own form of deep time, a release of the surface world to sink into hidden layers. As you drift off tonight, you'll enter a similar realm we've just explored, vast, silent, and without the comfort of certainty. And perhaps in that stillness, any minds that came before, if they existed, will meet yours not with answers but with a sense of shared company. So rest, not because the inquiry is over, but because you've carried it far enough for now. The past will keep. The world will turn. You are here. As we close the book on this era, please leave a like if this story helped you relax or learn something new. Comment which historical mystery you want me to open up in the next video. And subscribe to the channel to ensure you never miss a night in the archive.